Alright, ladies and gentlemen, welcome to the video notes for your pre-calculus textbook, Chapter 3, Section 2. This first portion of this section is entitled Logarithmic Functions, and it deals with what is a logarithm, how does it relate to the exponentials we've been graphing for several days. So, when we are looking at the idea of what is a logarithm, it helps for us to put that in perspective. Every operation that we use in mathematics has exactly one inverse operation. For instance, addition's inverse is subtraction, okay, and which we've done a billion times in our high school careers. If we wanted to solve this equation, since it says x plus 3, we would subtract 3 from each side, and that would give us our solution, okay? Same thing goes for multiplication. Its inverse, you should already know, is division. So for example, if we wanted to solve the equation 3x equals 7, we would divide each side by 3, and that would give us our answer, x equals 7/3. More recently, we have learned that the opposite of an exponent is a root. So for instance, if I wanted to undo cubing, I would use a cube root, meaning I would take the cube root of each side, which would give me my solution, x equals the cube root of 7. Well, that's where we're at now. Well, now we're dealing with, okay, what if our variable is an exponent? Well, the inverse of that is called a logarithm. And what would happen is we would simply rearrange this into logarithmic form, which would move the variable out by itself and give us something we could feed to our calculator. Logarithms should not be a new idea for us because we should have been introduced to them in Algebra 2. But if you weren't, that's okay. We're going to work under the assumption that you have never seen one before. So, as we saw on the last screen, when we solve equations, we apply an inverse operation to both sides of the equation to undo whatever operation is there and get the variable entirely by itself. For each operation, it's actually possible for us to rewrite the original equation using the inverse operation without actually carrying out that subtraction. What I mean by that is, if I have x plus 2 equals 5, I can write that with the subtraction shown without actually simplifying. And those are equivalent expressions. They mean exactly the same thing. So just like that, just like we can write numbers in multiple forms. Say, for instance, we can write a number in both a fraction and a decimal form, and those are equivalent. It is also possible for us to take an equation that is in exponential form and we can rewrite it in logarithmic form. Okay, these are exactly the same thing. We're not changing the problem. All we're doing is rewriting the equation in an equivalent form. So if you look here at the explanation, we have in that explanation a base for the exponent. Oops, a little bit too big. Let's make that smaller. We have a base for the exponent. In this case, the base of the exponent is a. That is the same base on the logarithm. Okay, so this exponential, the number being raised to a power, is known as the base, and that's the same a value you see in the logarithmic form. Then we have an exponent, b. Well, that's the same b we see by itself in the logarithmic form. That is your exponent. And then finally, we have the actual value that it is equal to, c. That is the number that ends up inside the logarithm when we write it in logarithmic form. These two expressions are exactly the same. There is absolutely no difference. Now, in Algebra 2, you probably saw it with an E, to be 100% honest. You probably saw it written as the Ben rule. Okay, these are exactly the same thing. There is no difference between these two. Okay? Okay, so there's two skills here. One is converting back and forth between exponential and logarithmic form, and the other is actually solving. So these first 8 examples here in example 1 and example 2, these first 8 examples are just converting. We're not going to simplify anything. All we are going to do is follow our rule. Remember that our rule says log base b of c equals a. There's actually log base a of, let's write exactly what was on the last page. Log base a of c equals b is exactly the same thing as b to the a power, a to the b power equals c. This is why I usually use the algebra 2 letters, because I have those memorized. Okay, so all we're doing is we're taking these expressions and we're rewriting them. So we have here a base. We have an exponent, and we have a value. And just like on the previous screen, all we're doing is rearranging those. So if we look at the expressions in A, B, C, and D, they each have a base. They each have an exponent. And they each have a value. So all we're doing is taking the exponential expression and rewriting it in logarithmic form. So that would be log base 3 of 9 equals 2. Log base 10 of y equals x. And by the way, there's a couple details we're going to go over in a minute here. And we'll go over it now. Log base 10 is known as a common logarithm, so we don't need to write base 10. If it's base 10, that's just log. And the reason that is our common logarithm is that is what our actual number system is based on Earth. We base our number system on the number 10. So that's considered to be a common logarithm, and we do not have to write the 10. You can. It makes absolutely no difference whether you include the 10 or not. All right, on to the next one. That would be log with a base of r of w equals t. And then this last one would be log base e of y equals 3x. Well, just like the common logarithm, a log base e is known as a natural logarithm because the base is the natural number e. So this is known as a natural logarithm, which is ln. So if we see that log base e, that's normally written as ln instead of log base e. All right, so then on the second half, we're going the opposite direction. It's the same idea, though. We still have a base. Okay, there's no number listed there, so we should know what that means, right? We still have an exponent, and we still have a value. All we have to do, I didn't do that right. All we have to do is rewrite it in the other format. Okay? So we're supposed to take these logarithms and rewrite them as 7 to the second power equals x. And you're not supposed to simplify it. All you're supposed to do is write it in the other format and move on. So the next one here would be 3 to the x power equals y. Then we have, this is really log base 10 of y equals 2, because there's no number, right? So that's a 10. That would be 10 squared equals y. And then this one is really log base e of c equals 4, which means e to the 4th power equals c. All right, moving on to solving. When we solve, we still treat these like we do a lot of different equations. What we want to do is we want to isolate the portion of the equation that contains the x. So in each of these cases, we're going to isolate as much as we can before we do anything with it. And then all we're going to do is we just need to understand that every logarithm is just an exponential written in a different form. And as such, we can use our conversion back and forth to solve equations. So, if we want to solve an exponential or logarithmic equation, that is where x is an exponent, or where an equation contains a logarithm, what we're going to do is we're going to isolate the exponential or log expression on one side of the equation as much as possible. Then we are going to convert that equation into the alternate form. So exponentials will be turned into logs, logs will be turned into exponentials. We will finish solving for the variable if necessary, simplify and or round the answer as directed by putting it into your calculator. Your graphing calculators, you're going to hit the math button, and then you're going to scroll down to the 10th option, which is listed as option A. It says like log base, something like that. Okay, and that will give you the ability to plug that value into your calculator. So, for instance, on example A, we need to isolate 4 to the x power. So we'd start by adding 2 to each side, which would give us 4 to the x power equals 9. That is isolated, so now we will rewrite that as a logarithm. Log base 4 of 9 equals x. And then we're going to go feed that to our calculator. So we hit the math button, scroll down to option A, which says log base. You'll notice that gives you the ability to fill in the 4 and the 9 on your calculator. And that gives us a value of x is approximately 1.584. We're told to round to the nearest hundredth, so that 4 would have us rounding our value down to 1.58. On letter B, we're going to subtract 5 from each side, which would give us 3 times 2 to the x plus 3 power equals 21. We can isolate that a little bit further if we divide by 3, which would give us 2 to the x plus 3 power equals 7. Rewrite that as a logarithm. Log base 2 of 7 equals x plus 3. We need to solve that a little bit further by subtracting 3, but it doesn't get subtracted from the 7, it just moves to the other side. So x is equal to the log base 2 of 7 minus 3, and we feed that to our calculator. Exactly as it is written, I'm seeing negative 0.192, which means we would be keeping that as negative 0.19. Okay, next one, we would subtract 3 from each side, which would give us negative 10 equals negative 4 times 3/5 to the x power. My 5 is a little, there we go, that'll work. Then we would divide each side by negative 4, which would give us 5/2 equals 3/5 to the x. We are then going to go in and we're going to rewrite that as a logarithm. Log base 3/5 of 5/2 equals x, and we're going to feed that to our calculator. So we're going to plug that in there, and that gives us x is approximately negative 1.793. Again, we are going to round that value down to negative 1.79. All right, that just leaves going the opposite direction. So now we're going to solve some logarithm equations, and we are going to solve those out the same way. We need to isolate the logarithm, so we're going to subtract 5 from each side, which would give us 2 times the logarithm base 3 of x equals 5. Divide by 2 to get the logarithm as much by itself as we can, which would give us log base 3 of x equals 5/2. Rearrange that into an exponential, would give us x equals 3 to the 5/2 power. And then we type that into our calculator, and just like before, we're going to round that to the nearest hundredth. So that would be x is approximately 15.59. Okay, 2 to go. Next up was subtracting 4 from each side. That would give us the negative log base 5 of 2x minus 1 equals 0. We would divide each side of that equation by negative 1, which would give us log base 5 of 2x minus 1 still equals 0. We would rearrange that into an exponential equation, which would give us 5 to the 0 power is 2x minus 1. Remember that anything to the 0 power is 1. Add 1 to each side and divide by 2, and we get x equals 1. Okay, last one. We would start by multiplying each side of the equation by 5, which would give us the natural log of 2 minus x equals 5. Remember that that really says log base e of 2 minus x equals 5. So we're going to rearrange that into the exponential format, which would be e to the 5th power equals 2 minus x. Now we could move the 2, but it's easier to move the e to the 5th and the x to make the x positive, which would give us x is 2 minus e to the 5th power, and we feed that to our calculator. That would be negative 146.413, so x is approximately negative 146.41. Hopefully that video lesson gets you to the point where you can attempt the homework while you're stuck at home with C19. Email me if you have any questions. Thanks.